Hey everyone, and welcome back to the final part in the Let's Make Google Translate series. Today we're probably going to be getting into the best part of this. So far, we've already covered all these steps you see here, the first three, and now we are actually training our model and testing the model. So we'll actually be able to use what we make to translate something to cheat on our, our language homework. Don't actually do that. That's bad. You shouldn't be doing that. But anyway, to be fair, if you can do machine learning, hopefully you can also learn a language. But let's get into it. I think this is probably what most people have been looking forward to. If anyone skipped through to this part, by the way, I don't blame you. This is just all this sort of work we did transforming the data. You should be able to understand this without that part though, so no big deal. Though if you do want the previous episodes, they are there. So here is what we are going to do. We're going to start by specifying some parameters. We want to specify how many epochs we want to train for. Let's say 5. Let's start with 5. 5 seems reasonable to me. Let's do a batch size. We'll start with 16. 16 is what Google Colab should be able to do using a GPU with the model we're using. So I've done some testing. 32 is too much. 16 works just right. Print frequency. We're going to want to print updates, right? So let's make that 50. That will mean every 50 batches we print an update, how much loss we're getting and stuff. Checkpoint frequency. I'm actually not going to do this. I'm too lazy to make a checkpoint right now. Learning rate. Let's do something like 5e -4. I just did a little experimenting. This worked well for me, though. Generally, anything between 1e -3 to 1e -5 will probably work fine for you too. Then we need the number of batches. This is going to be just the numpy.ceil of the length of the train data set divided by the batch size, right? So it's just the amount of examples we have in our data set divided by the batch size is how many batches we have. Yeah, it should be too hard. Total steps equals the number of epochs times the number of batches. And then finally, we're going to be using a warm-up for the learning rate. What that essentially means is that the learning rate starts at 0. It slowly or fairly fastly warms up to its peak and then starts going back down. We're using what's called a scheduler, and this can help the learning be a little bit more stable. Honestly, you probably don't need it here, but just for good measure. And if you've never used one before, it's a good learning experience. And warm up steps is just going to be, I'm going to say total steps times 0.01. So just 1% of our steps, the first 1% will start as warm-up steps. Next thing, the optimizer. We are using an Atom optimizer. This Atom optimizer is given by Hugging Face. It's pretty standard, I think. We pass in our model parameters. And if you are just skipping to this point, by the way, the model we're using is MT5. It is a multilingual translation model, or not translation, just language model that works super well for all sorts of language tasks. Highly recommend looking into it. MT5 paper. You can see I've looked it up before. The paper's, it's just about how, I guess, they do the training primarily, some benchmarking, some interesting stuff if you want a good read. And then we need the scheduler, like I just talked about. So the schedule, or I'll just go ahead and copy this too. I'm getting a little lazy. I'm recording all these back to back, so get linear schedule with warm up. This is what I just talked about, the warm up. So we pass in the optimizer, the warm up steps, the total steps, and that should be all we need. We're almost there to the training itself. Let's make a losses array. This will track our losses so we can graph them at the end and see how we actually perform. It's always good to see how you're doing. Yeah, I guess let's jump into the actual training code now. So we have for epoch IDX in range of n epochs. So this is our outer epoch loop. We want to first randomize the data and get a new data generator, right? So if we do this, this is the get data generator function we made right in the previous tutorial. So if you haven't seen that, that's what this is. And it just will, it's a generator for our data. It will return us batches of data of random pairs, or of pairs of random languages. Next thing we want to do is loop through our batches, right? So for every batch in the total amount of batches, and I'm using TQDM Notebook here. If you've never seen this, it just gives us a nice little progress bar when you wrap it around something. So, dry throat, sorry. That's all that is. But what we're getting from our data generator is, most importantly, the input batch and the label batch. These are input token IDs and our expected token IDs. Now we can actually finally we've come this far, pass things through the model. So, or actually no, sorry, there's one more thing we need to do before that, and that is actually optimizer. That zero grad. Don't forget to zero grad your optimizer when you're doing PyTorch. This is essential. It will zero out all our gradients before we do any calculations. Finally, we have the forward pass. The forward pass of the model. Oh yeah, getting exciting. Oh, this one. The forward pass of the model, we just pass in our input IDs and our labels. You might be thinking, why do we need our labels? We actually don't need the labels. We can just do this. The reason I'm passing the labels along with this, right, is this specific model also calculates loss for us if we pass it in. So, you know, just saves us some extra steps later of calculating the loss. I believe the loss it uses is just a categorical cross entropy. I'm not 100% sure on that, but I believe that's what it is. Yeah, some sort of categorical loss. Next thing we want to do, right? So these are our predictions, right? Our predicted outputs is we want to get the loss. We don't actually care what the predicted output is because we've already had the loss calculated for us. We just do model out and we can get the loss from that. Let's go ahead now and append the losses, or the loss, to our array we made earlier, our list we made earlier, loss.item. Item will just take this PyTorch item and turn it into a scalar, NumPy scalar, I believe. And then we want to do our back propagation to train the actual network. This is what will update the weights. So loss.backward will do all the calculations, go back through the network, our MT5, update all the weights, so we're actually learning as we go. Or it will do the calculations. What will actually change the weights will be optimizer.step. That will actually apply those gradients. And then we also need to do a step for the scheduler. And this will change the learning rate. So it does the first warm up and then slowly goes down to be more stable learning. This is really all we need. It's really quite simple. I'm going to copy and paste one more thing in here. As you might remember, I had this print frequency variable up here. I'm just going to go ahead and every 50 batches, we are going to head and calculate the mean loss for the past few batches. And we're going to print it out, print out the epoch, print out the step, and that average loss and learning rate, just to help us keep track of our learning and make sure we are actually learning. And that's it, really. This will work. So there is something I want to add after this, but let's go ahead and try this out and see if our training actually pays off. What we should see is, okay, it's running. Yours might be a little slower, by the way, if you're not on the pro version of Colab. I pay for like the upgraded version, but it should still work just fine. Cool. Average loss from 13 to 6. That's a good. It should decrease 5. Okay, it's going down. You can see the learning rate went up a little bit, and now it's going back down. The 4. This is looking good, right? The learning rate, or the average loss, is going down. And remember, the losses are error. So as long as that's going down, we are in the green. As long as we didn't make any other mistakes. You know, we could have made a horrible mistake, but I'm hoping that's not the case. This is awesome. It's training. There's 2 issues right now, though. One is that we don't know if we will be overfitting here, right? If we keep training, our model might be so big. It's the small version, so it's probably not, but it might be so big that, because even the small version is hundreds of millions of parameters, it might just remember the data, especially because we're not using a particularly large data set. If I remember correctly, it's like 18,000 examples or something, I guess times 6, because we have 6 different language pairs. But that's not a lot. That's not a lot in comparison to, you know, or relatively. So we want to track the testing, so that the evaluation on the test set too, we can get the loss for that. I'm going to go ahead and give you guys a function I went ahead and pre-made for this. And the reason I'm not going to do this is it's exactly the same as what we're doing here, right? We get a data generator. For the test data set though, we pass that through a model, we get the loss, and we just output the loss. So it's the same thing that we're already doing. You can see here's the data generator, we get the batch data, I set a max number of iterations in case we have a lot of test data. That shouldn't be an issue though. And then model out. Yeah, we just do the forward pass through the model, and we append our losses, and then we give back the mean of our losses. So it's the same thing we're doing here, but with the test data set. What I am going to go ahead and do is say at the end of each batch, we can go ahead and do this, right? So to do this, all we need to do is call our eval model function. That's what I just gave you. Put in the test data set, not the train data set, right? So that's our test loss. We can say, we're not saving the model. I do that on my other one though. Test loss of, and we're just going to format this test loss to be up to 3 decimal places. And that's it. So every epoch, we should see if we're going up or down. You can do this more frequently if you want. Just for the sake of it, I'm actually going to just run this right now to show you that it works. We should be able to run this and get a test loss. Oh, no, it didn't, because I indented like an idiot, big idiot. I'm sorry, it's getting late here. Test loss 3.4, So if we look back, 3.4 was roughly what we were on the training data set. So unsurprisingly, very early into training, we're definitely not overfitting yet. Everything's still looking pretty good, So what we would normally do now is we go through and we'd run this, and you can absolutely go ahead and do this yourself if you're following along. And go ahead and, I'd say wait 2-3 epochs until this starts to plateau. 5 if you want. Make sure you're not overfitting. If the loss here, if our test loss starts going up, that's a bad sign. That means we might be overfitting. But other than that, we should be good. I'm not going to leave you guys hanging here though. I have more. I have my own kernel I've used here. This is my personal example. There's a few minor differences. One key difference is that I'm actually using the base model, which is a bit bigger because I have access to better GPUs than what the normal Colab offers. So I'm able to do that. You can actually see my training here. This is actually not starting from the beginning. This is a preloaded model. That's why it's starting from a loss of 2. It actually started from like 16. But you see we're going all the way down here. It's not quite the same as the test loss, but that's fine. But I want to show you my results. So what you can expect if you run this for a while. And I say run for a while, I only ran this for like, I think less than an hour. It really wasn't that bad at all. So it's kind of crazy the results you can get with less than an hour. You can go ahead and graph these results though. So I used Seaborn to graph these. All I'm doing is I'm taking the losses and I'm just smoothing them out and graphing them. And you can see we get a pretty good decrease here. You can see on each epoch, the end of each epoch, we have a steep decrease, right? So here, here. That means it could be overfitting, but I've done some testing and I don't think it is, or at least not too much. So we should be in the clear. I got down to roughly 1.5. Oh, runtime disconnected. Oh, that is a shame. I'll be back in 1 second because I need this to go. I actually need this so I can show you guys the demo. I'm back. No need to fear. So I got everything running again. This is the graph. You've seen this. We see the losses going down. That's great. We can go ahead and do some manual testing. All I'm doing is taking one of these test sentences, and I guess let's take one in English and translate it into Japanese. So this is just the encode input string we were using earlier. We're encoding this test sentence. Once we encode it, we are passing it. Where I lost this. We're converting it into a string just so we can see the raw input text. Remember, because some of this is going to be truncated, which is a bit unfortunate. So, target language. Okay, 1 more second. Okay, false alarm. I'm just an idiot and tired. Remember, this was not JP, it was JA for Japanese. So let's go ahead and run that. There it goes. You see our raw input text is, it has been confirmed that 8 thoroughbred races of blah, 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 and so on. You can see this actually starts with a JP tag because we want to translate it into Japanese. And we get, it truncates it here, right? Unfortunate, but kind of the limit with this model because we're using a pre-trained version. So we can actually go ahead and use this generate now, right? this is pretty cool. We have the input IDs that we just got from this. So this will be passed through the model. Num beams. So this generate method is pretty interesting. We can't dive into the sort of details of it because it's quite complicated and that would be a whole nother video, though tell me if you want that in the comments. And just by the way, before we get into the sort of finale of this, what we've all been waiting for, the actual translation, if you do like this content, this stuff takes a while to put together. So the subscriptions, the likes, I really do appreciate them. But either way, back to the video. The number of beams, the more accurate you can expect this to be. And we can also specify how many sentences we want to return. So we're just going to go through the token set of the output tokens. So because remember, we call this generate. It gives us 3 sentences because that's what we specify. And this is our trained model now. We can go ahead and decode this token set. So this token set is the output tokens we get, or the token IDs. So we're decoding that and we get English. Let's see, or Japanese because we were translating to Japanese. So, I mean, we can go ahead and see how accurate these are, right? Pop them into Google Translate. It's funny, we're using a translator to check our translations, but 8 tropical races on the something Randwick's race coast. Oh, let's see. It's been confirmed that 8 thoroughbred racehorses at Randwick Racecourse. That's pretty close. That's pretty close. It's definitely not perfect, but you can see definitely some stuff is getting through here. Now it's really time for the best part. We're making our own little app here. So this is the code behind it. It's very simple now that we have our model trained. I've used Google Colab's forms, and the way you can make these forms where you can enter this stuff right here, if you've never done this before, is let's make a new cell real quick. Right click and hit add a form. You can see there's a little title, so we put in our title, and right click again and say form, add form field, and we can input something like, let's say we want input, you can do different types of things. So let's say we want a string input, right? So our input text, we just put that there and it adds this for us. And then when we run this cell, whatever variable we put in here gets populated over here. So it's pretty cool. The way I've set this up is that we have the input text, and then we also have an output language. So you can actually go through and specify each of these 3 languages that you want to translate into. Once we do that, we just encode the input string, and then we do the generate. I'm using 20 beams here to be a little bit more accurate. I've also used this other parameter, length penalty. What this does is it will penalize it for being too long. What I found is this helps a little bit with repetition and things just going on forever. There are some other parameters like an actual repetition penalty and stuff. You can play around with it. You can probably get better results than me. I only spent like 5 minutes on this specific thing because I'm tired now. But then we print it out. We print out our original text and what it translates into. So, I mean, that's it. Let's go ahead and play around with it, I guess, right? We put all this work in. If you've been following along, definitely give it a go. Or if you haven't been, you can also check the comments below. I have this on GitHub and Colab, so you can go ahead and run it yourself if you just want to try it out. But let's try it. So we tried this as a test. Maybe let's try something. Let's try something funny. Let's do like a circular thing, right? So this is a test into Japanese. Let's now take this Japanese and translate it into Chinese and see what we get. I don't read Chinese, by the way. I only know Japanese and English, so unfortunate. So I don't know if this is right, but let's try this, right? Let's take this Chinese and try and translate it back into English and see if we get the original. This was a test. Okay, so we were pretty close, but not quite. But that's pretty good. Fairly simple. So maybe let's try something a bit more complicated. Let's do something from like English to Japanese again. Let's do a guy was a surfboarder ran into a shark, because why not? Stepping up the notch a little. This should be a little bit more difficult. I cannot read this for the life of me, so let's stick this into Google Translate and see what the real Google Translate. Sorry, I shouldn't say real Google Translate. This is just as authentic. Slick Blue Translate. I think it could be a new competitor, but anyway, the swimmer was in a flock of sharks. That's pretty similar. Swimmer. So, oh, gee. Okay, I'm sorry. We're not doing that. Oh gosh. what else should we try? I don't know. This is actually pretty fun to play around with. So if people are interested, let me know in the comments if maybe I should just do a whole video trying out our own translator and having some fun with it. Maybe we can find some interesting translations. Maybe leave in the comments what you want to see, if there's any specific things you want me to try, or try it out yourself. You know, you have the code, you have the know-how now. But that's it. That's all I have for you all. I hope you enjoyed it. I know I've said it, but last time you subscribe to the channel, I really do appreciate it. I release a lot of cool content like this. But that's it. So I thank you very much for watching, and I hope to see you in some of my other videos. Catch you all next time.